everyone, welcome to the session Programming for Problem Solving. Myself Navya, I am an assistant professor from the Department of CSIT in MLR Institute of Technology. In previous session, we have seen operators of part 2 which are included in C programming. In this session, we are going to see part 2 of the operators. So, what are the leftover operators which are in the previous session? We are going to see in this particular session. So, here in this session, we are going to see what are logical operators used in C and what are the bitwise operators and what are assignment operators and what are ternary operators. We are going to see in this session. Coming to the logical operators. Logical operators are used to combine two or more constraints together using these operators. So, this is used in evaluation of original condition in consideration. So, if I want to go, what was the result of the operation is the Boolean values, whether it was a true or false. When it was true, it will return you 1. When it was false, it will return you 0. So, this was the result you will get. When I want to go with two operations, two particular conditions. If, for example, if I am taking a variable, I am reading a variable, my variable, if I want to go with two conditions, that variable should be divisible by 5 as well as it should be divisible by 11 also. In such particular conditions, if I am going with n number of conditions, if I want to combine those conditions together, we are using logical operators for the sake. Here in the logical operators, there are 3 logical operators in C. First one is logical AND, logical OR, logical NOT. For the logical AND, you will use 2 ampersands. You can't use 1 ampersand for the logical AND. For the bitwise operators, you have to use 2 pipe symbols, and for logical NOT, you have to use exclamatory mark. And see here, for the logical operators, if x value is 6 and y value is 3, if I am saying that x less than 10 and y greater than 10, if both are true, then only it will return you the true. Similarly, you will take one constraint here and the other constraint here, and in the middle you will use a logical operator. Similarly, logical OR also used, logical NOT is used with one particular constraint. So, this is all about logical operators. So, let us go with one simple example program here. So, if I want to check the logical AND, so I am going with logical AND equals to, okay, I will go with the expression here, A greater than B and A not equals to B. If this is the condition, I am checking whether A greater than B as well as A not equals to B. Similarly, the same condition I am going to take for OR also. Next, NOT of A greater than B. What it results, let us see. But before this, let us go through the truth tables. Let us go to the truth table. My first one is A, B, A and B. A or B, not of A. If this is the case, if A value is true, first relational condition is true, second condition is true. Okay, we'll go for multiple conditions. If first condition is true, second condition is false. First condition is false if second condition is true. Or if both the conditions are false, then what I have to check? When it comes to the A and B, if both conditions are true, then only A and B will be true. Or else in any other conditions, it will be false. If one is true also, it will be false. When it comes to the A or B, if one condition is false, if two conditions are false, then only A or B will be false. All the other conditions will be true here. Not of A is reverse of that particular A. If A is true, it was false. If A is false, it was true. So this is how the logical operators will work. Okay. So when I compile this program, see, A greater than B is true and A greater than B is false, as 2 is not greater than B. So you will get false here. So when I go to this particular situation, 2 is not greater than 5. So it was false. So 1 is false, it will be false. So it has returned you 0. See here, A greater than B, 2 greater than 5 is false. But 2 is not equals to 5 is true. So if one condition is true, when you use or, it will be true. And the reverse of this one, 2 greater than 5 is false. So the reverse of false is true. So you will get 1. So this is how the logical operators works in a programming. Coming to the next operator, bitwise operators. Bitwise operators are used to perform operations on bit level. Okay. So what is mean by bit level? You have to know. So the operators are converted to bit level and then the calculation is performed on the operands. So here the mathematical operations such as addition, subtraction, multiplication can be performed at bit level for faster processing. Okay. So some bitwise operators are bitwise AND, bitwise OR, bitwise XOR, bitwise ones complement, bitwise shift left, shift right. So coming to the bitwise operators. If A value is 0 and B is 0, if both are false, the same as it is as and OR will be same as logical operators. If two bits are 0, then it will be 0. If one in the AND operator, if 2 1, then only it will be 1, or else it will be 0. In the OR operators, if 2 are zeros, then only it will be 0, or else it will be 1s. And when it comes to the XOR conditions, if any two different values comes, then it will be 1, or else it would be 0. Coming to the NOT operator, complement operator, if A is 0, NOT of A is 1. If A is 1, NOT of A is 0. So coming to the bitwise operators, how it would be performed. First, whatever, if A equals to 5, B equals to 6. This, when you are using bitwise operations, these values will be converted into binary values. As these are decimal values, these will be converted into binary values. So let us go with a quick binary conversion process. If 5 is there, when I divide with 2, 2 2s are 4 and the remainder is 1. Similarly, 2 1s are 2 and 0 is the remainder. So the binary value of 5 is, you have to go from the low level to high level. 1, 0, 1. Similarly for the 6. When I divide 6 with 2, 2 3 is 6, remainder is 0. When I divide 2 with 3, 2 1s are 2 and the remainder is 0. So, remainder is 1. When I divide, so here, what was the value of 6? 1 1 0, not 1 1 0. So 6 binary value of 6 is 1 1 0 and binary value of 5 is 1 0 1. How can you say whether 1 0 1 is a value of 5 only? You can have simple steps. 1 byte consists of 8 bits, right? So 1 2 3 4 6. So 1 0 1. The remaining are zeros. 1 byte consists of 8 bits. So 8 ones are zeros. So here you have to calculate with 2 power 0, 2 power 1, 2 power 2, 2 power 3 and so on. So as 0 into something is 0. So 1 into 2 power 0 plus 0 into 2 power 1 plus 1 into 2 power 2, which is 1 into 2 power 0. 1 into 1 is 1 plus 0 into something is 0 plus 2 square is 2 into 2 is 4 into 1, which is 4, which is equals to 5. So 101 is a correct, as it was a binary form of decimal value of 5 is y. Binary value of 5 is 101. So what we will do is, let us see A equals to 5, B equals to 6. Okay, 1 0 1 1 1 0. When I perform AND operator, what happens? 1 0 is 1, 0 1 is, 1 0 is 0, 0 1 is 0, 1 1 is 1. So what is the value of this? 4. You will get 4. Similarly, for the OR, 1 0 is 1, 1 0 is 0 1 is 1 and 1 1 is 1. So it is a value of 7. When it is XOR case, 1 1 is 0, 0 1 is 1, 1 0 is 1. So which is 3. Okay, these are the values of these are the binary value of 4. This is the binary value of 7. This is the binary value of 3. So when you write the program, so I am going to write the same program. My A value is 5 and my B value is 6 here. So when I perform the bitwise operations, A and B equals to similarly A OR equals to, I am writing decimal format. XOR is a cap symbol, you will get and I am going to have the NOT value also. If I go with 101 NOT, complement of A, which you will get 1 means 0, 0 means 1, 1 means 0, which is the value is 2. So we'll have that one too in the programming. Printf complement of A equals to percentile T comma A. So we'll see, we'll execute this program and we'll see what is the values I have got. Shall we compare with this values? See what all the values I got is when I do AND, A and B equals to 4 I have got. When I do OR operation A or B, the value is 7 and When I use XOR operations, A XOR B, it was 3. When I use NOT operations, I have got 2. But it has shown you -6. Okay. So this is how the binary operators will work. Bitwise operators will work in similarly. Similarly, you are having other two operations called shift left and shift right operations. So how it would be happen? So I already said you 1 byte consists of 8 bits of memory. If my value of x equals to 7, when I use left shift of 1, this 1 will be deleted and 10 will be added from the left side. Similarly, if you are going with 3 zeros will be added here. If you are going with with 2 zeros will be added here. So the value of these will be calculated as per decimal thing. Similarly, for the right shift, so if you are having 1, 0, 1, so remaining are some x equals to 5. If I am taking 1, 2, 3, 4, 5 zeros. When I write x left shift of 2, the two values will be added to this side. These two values will get deleted. So 0, 0, 0, 1, 0, 1, 0. So this is how the left shift will be working. The purely reverse of this is right shift. So as you are inserting the values here, you are deleting here. Similarly, when it comes here 1, 0, 1, 1, 2, 3, 4, 5. If I want to use x right shift of 2, so these two values will be deleted and it will add these two zeros from the right side. See here, when I was using this, 29 is my value. This is the binary format of 21. So when I use 1 right shift, 1 0 will get deleted. Here this 0 got deleted, and next for the second right shift, 2 zeros will be deleted. For the 3 right shifts, 3 will be added to this particular row. So this is how the binary bitwise operators will work. Coming to the assignment operators. Assignment operators are used to assign value to the variable, which is equals to. Equals to, if you write a equals to 5, the value of 5 will be saved in a. The left side operand of the assignment operator is a variable and the right side operand is a value. So the value of on the right side must be same data type of the left side. Otherwise, the compiler will raise a error. So this is also an important note point. So these are the assignment operators available in C. If you write equals to, if x equals to y, I already said y value, whatever the value of y is there, that will be saved in x. Next, plus equals to. If you want to write x equals to x plus y, we can simply write that would be converted into x plus equals to y. Similarly, minus equals to means x minus equals to y means x equals to x minus y. Star equals to means x star equals to y means x equals to x star y. Slash equals to means x slash equals to y means x equals to x slash y. Modulus equals to x modulus equals to y means x equals to x modulus y. So this is how the assignment operator will work. Let us see a small example. I am going to take only the 3 operators. A plus equals to B, A minus equals to B, A equals to B. Okay, when I compile this, what was the values I have got? A plus equals to B. What is A value? 5 plus 6. 5 plus 6 is A value will become 11. Next, A minus equals to B. A value has become 11. 11 minus B value is 6, which is 11 minus 6 is 5. Next, A equals to B. 11, A value is 6. So, it was, A value has become 6 in this step. So, A value, A equals to B means we are getting A value as 6. B value is 6. 6 will be saved in A. So, A value has become 6. This is how the assignment operators will work. This is assignment operators. So coming to the summary of this session. So in the last session we have seen some of the unary operators and binary operators. Here we have seen the one is ternary operator. Okay. So coming to this operators, binary operators. Some of the binary operators we have seen. The first one is bitwise operators. Bitwise operators are bitwise AND, bitwise OR, bitwise NOT, and XOR operators, left shift and right shift. Whereas logical operators are logical AND, logical NOT, or logical NOT. And we have seen assignment operators also. So in assignment operators, we will have equals to, plus equals to, minus equals to, star equals to, slash equals to, and modulus equals to. These are some of the operators we have seen, and the leftover operator is ternary operators that would be seen in the next session. Thank you everyone.